Hello everyone, welcome you all to AIT Pathsala. My name is Anupcha. I'm your instructor for this free course on data structure and algorithms in Python. I have created this course for you with immense passion and dedication. So let's embark on a transformative journey into the realm of data structures and algorithm with our comprehensive playlist tailored for aspiring software engineers and coding enthusiasts. Join us as we dive deep into the fundamental concepts, intricate algorithms, and practical implementations using Python. Whether you are a seasoned programmer looking to brush up on your skills or a beginner eager to explore the fascinating world of algorithm, our playlist offers something for everyone. Subscribe now and embark on a journey to coding mastery. Now, I want to do a quick walkthrough of the curriculum and talk about what to expect from this course. This course explains the concept from very basic to advanced. So it's advisable not to miss any section before you go to the next section. The very first section is introductory section, in which I explain basic content such as what is data structure, what is algorithm, and why we need them. Then the next section is called recursion, which is really very important stuff. Recursion is used in many algorithms. So it's very important to learn recursion before diving into the deep data structures and algorithm, because it comes into picture later on in many of our algorithms. And there are a lot of interview questions about recursion, and main ones are explained in cracking recursion interview section. Then the next topic is Big O notation. It is a way of describing or talking about the performance or efficiency of the code. So we use this section all the time. So, and there are many different questions that are related to Big O. So the most asked questions are explained here in this section of cracking Big O interview questions. Then we move on to the next section called arrays, in which we explain different type of arrays such as one-dimensional array, two-dimensional arrays, and we have introduced how they are presented in memory, and we have calculated time and space complexity for array operations. The next we shift over to talk about Python lists, which is very similar to the arrays, just a small difference. So we explain the difference between lists and the arrays. Then we analyze the interview questions related to arrays and Python. Then from here, we continue to explain inbuilt data structure of Python, which are dictionaries and tuples. And we have analyzed these data structures by using Big O notation to calculate the performance. Then we continue to the longer section of this course, which is called linked list. We have covered all details of linked list with performing all operations on different types of linked list, such as singly linked list, circular singly linked list, doubly linked list, and circular doubly linked list. Additionally, we have explained famous interview questions about the linked list in a separate section. Then we move on to do two more additional data structure, which are stacks and queues. And these are very commonly used data structures. And here also common interview questions are explained about them. Then from here, we start another very detailed section which describes whole tree data structure, in which we include binary tree and the main concepts of binary tree, such as pre-order traversal, in-order traversal, post-order traversal, and level order traversal. And then from here, we continue to do binary search tree and then AVL tree. In AVL tree, we have covered important concepts like left-left condition, left-right condition, right-right condition, and right-left condition. And we have implemented these conditions in inserting or deleting a node in AVL trees. And this is a fun section in my opinion, because there are a lot of challenging problems that we are doing over here. Then we are going to the binary heap, which is related to trees, but a very special case of trees. And we talk about common operations of binary heap. And finally, we go to the last type of tree, which is called trie. The trie takes characters as a node, and so it is very useful, especially when developing applications. Then from here, we go to the hashing section. So here we will talk about a very particular data structure, which is very interesting. So here we explain how Python building data structure work and how they are implemented behind the scenes. So from here, we get to the sort of second part of the course. So up until this point, we have been talking about different types of data structures. But from this section, we will start to talk about different types of algorithms. So from this slide to the end of the course, we will talk about different types of algorithm, which are very essential concept of computer science. So we move on to the sorting algorithms, in which we will learn several different sorting algorithms. We start with bubble sort, which is often considered the easiest one. And we move on to the selection sort. Then we move on to the insertion sort. And these three form a little group of intermediate or elementary sorting algorithms. Then we move to the bucket sort, and then merge sort, and then quick sort. And this sorting algorithm all involves recursion and big O notation. That's why it's very important not to skip those lectures before you come over here. Then we finish up this section with heap sort. Then from here, we go to the another detailed section, which is called graph algorithm, something that a lot of people are intimidated by. So here first we start to explain graph data structures and so how to implement them using Python. Then we continue to implement graph algorithms like breadth first search, depth first search, which are using graph traversal, and then we continue to find topological sort for a given graph. Then from here, we'll continue to solve problems like single source shortest path problem and all pairs shortest path problem. So we will solve these problems using 4 different algorithms such as breadth first search, Dijkstra algorithm, Bellman-Ford algorithms, and Floyd-Warshall algorithm. And we will also talk about why we cannot use depth first search algorithm for these problems over here. Then from here, we will continue to the minimum spanning tree, which is a special type of graph, and we will solve this problem using 2 different algorithms like Prime's algorithm and Kruskal algorithm. Then this will conclude the graph section, and we move on to the next session, which is called the greedy algorithm. So here we will talk about which algorithms use greedy approach, and we solve problems like activity selection problem, point change problem, and fractional knapsack problem using greedy algorithm. Then the next section is divide and conquer algorithms. Here I will talk about main properties of divide and conquer algorithms, and we will learn how can we identify and solve problems using divide and conquer approach. Then we will solve problems like number factor problem, horse robber problem, convert one string to another string. Then we will learn zero knapsack problem, longest common subsequence problem, longest palindromic subsequence, or substring problem. And also we will learn minimum cost path problem using divide and conquer approach. And we will create methods in Python for those problems over here. And from here, we will continue another very detailed section, which is called dynamic programming. I know many people are curious about learning dynamic programming. So here I will talk about main properties of dynamic programming, such as optimal substructure property and overlapping subproblems property. Then we will learn two methods of dynamic programming, which are top-down memoization and bottom-up with tabulation. Remember, this is a memoization. This is not memorization. So please don't confuse top-down memoization with memorization. And the second one is bottom-up with tabulation. And I will show you 4 steps to convert divide and conquer algorithms to dynamic algorithms. Then we continue to learn some common problems that can be solved using dynamic programming, such as number factor problem, house robber problem, convert one string to another string problem, zero knapsack problem using dynamic programming. So after this section, I have created a challenging dynamic programming exercises section for those who like pain and misery, because these are quite hard problems. So if you are interested to solve hard problems in dynamic programming, you can continue with this section over here. And finally, we will reach the Wild West section, which include coding exercises for all topics that we have explained in this course. So that is where we finish this course. But this is not the end, because I will keep on recording new sections based on your requirements. So hopefully you will enjoy the course. So see you in the course. Keep learning, keep smiling. Take care. Bye-bye.